Okay, so first thing we should mention is sorry about the midterm. I hope I didn't ruin anyone's life by not having it ready like I said I was going to on Thursday. My, how time flies. So I am 1, 2, 3, 4, like 5 days late. This is available as of this morning, the midterm. I put it as its own module at the very top of the page to try to help people find it. Some things I did to it is I made it a time limit of 3 hours. I think that should be enough. If anyone thinks that's not going to be enough, let me know. You will have to use Respondus to take it. So please, like I said in my message, please take the Respondus quiz first and make sure that works. And that Respondus quiz is in week 8, where the midterm was supposed to be. Wait for it. Here we go. It's this Respondus practice quiz requires a lockdown. Oh my goodness. Sometimes I just want to love Respondus with all my heart. I mean, Canvas. So it's this thing right here. And there is really no grade for it, although it might affect your grade. If it does, I'll fix it. It's just a matter of, hey, can you turn on your camera? Do you have the software downloaded? Is everything working? I did click a button that should allow you to do it on the iPad if needed, and it records you, and kind of like it's a way to keep you from using things you're not supposed to. So take this first, and then you take this midterm at your leisure when it best fits you. You're not taking it during class time because I will be doing class stuff during class time. So you're going to take it tonight at 1 in the morning because that's when you function best and your kids are asleep, and that's just when you want to do it. You know, you take it whenever you want between now and the 31st. Oh, Halloween night. Ooh. That's like a bad time. If we need to mess with these things, like if these dates are problematic for you, let me know. Here's the thing. Please don't start the test and then stop it and ask me to do something. Just make sure when you're ready to take the test, you've got roughly 3 hours set aside to take it. I don't think you'll need that many hours. It is, if I printed it and administered it in my in-person class last Thursday, and it was 6 pages long, 11 questions. You know, with parts A, B's, and C's and stuff. It looks very similar to the Unit 2 review and Unit 1 review B's smashed together. Remember, you are allowed, I never remember how many pages I said. Was it 3 pages, double-sided handwritten notes? 2 pages? I think it was more than 2. I think it was 3. 1 for each unit, and then 1 more for good measure. You don't need that much, honestly, I don't think. But you're allowed that. Okay, 4 pages, great. 4 pages double-sided. Let's pretend that's what I said. It probably is. I'm sure it is. We could prove it with recordings. So take some time putting that together. There are videos stating that. Like if we go to my YouTube channel, ooh, easy. YouTube channel content. Let's see what this does. Thank you to someone that said, hey, could you please label what the videos are instead of just dating them? And I'm like, yeah, that makes a ton of sense. Why wouldn't I do that? So they are now labeled by section. What's going on here? Come on, internet. There we go. So for example, it looks like I need to fix the 9.7. Unit 921 is when we did the unit review A work through, and I wrote up a reference sheet suggestions for all of unit 1. 1019 is when I did a unit 2 review, working through the A and talked through all the write-up for unit 2, the reference sheet. So that's where I would look if you're forgetting what to put in there. And I'm also happy to look at what you've written down and say, well, do you have the relative error formula on there? Do you have blah, blah, blah. So that's that. Just a word of advice. If you have limited time in your life, focus all your time on submitting outstanding projects. They are 50% of your grade. The midterm is 10% of your grade. All right, so the bulk of your grade is based off of these projects that you're submitting to me. So just keep that in mind. Okay, questions?
Hi, Eric.
Talk to me. Hello.
So I was reviewing 2.2, and for some reason I'm like just struggling piecing it together. Like I know when I get started, like how to do everything, but it's the getting started from the word problem itself is what's giving me difficulty. Does that make sense?
Yeah,
Okay.
it does. 2.2 is the rate stuff, right?
Yes. So it's like when you're converting from like a decimal to a whole.
Like this one.
Yes.
So yes, this is also 1.6 material, I think.
Okay.
Was it this problem specifically?
No, actually that one I think I did pretty good, and I reviewed the video for it and the numbers look right. But it was number 2 that I just have like a hard time getting started on. Like my brain just doesn't want to do it.
You're gonna hate this.
$2 per gallon.
I mean, you're gonna hate this because this one is simpler than the one above it.
Okay.
Ready? How
So
many
maybe I'm
dollars did I give you?
overthinking it.
Yeah. How many dollars did I give you? $4.49. So dollars on top. How many gallons did I give you?
Half a gallon, so we just double it.
Yep.
Okay.
I mean, you
so
can do it
was
like
overthinking
this, but yeah, like that one. So this one, it's how I've taught you to mess with these. I hope that's the right answer, by the way, is to, write this fraction and do this thing and then divide the top and the bottom. And then I give you a fraction as the divisor, and that, right, is awful. And then you're like, really? I just multiply by 2? Is that really it? That seems too simple.
Well, no, I kept referring back to like question 1 and then reviewing the book, and I'm like, this doesn't seem right. So I'm glad you said that. Thank you.
That's it. That's all it is. And really, in any of these problems, look at this and write the numbers based on what I've given you. Like, so for this one, we could start with 1 gallon over 8.98. And then that one, just smash in your calculator like I've been saying.
Okay.
In other words, we're going to figure out how many gallons can we purchase for $1. This one, by the way, no one uses in real life. You don't unit shop by the number of units per $1.
Okay. Thank you.
You are welcome. Anyone else have a question about anything? I'm always happy to entertain questions. Don't read text and teach class. Oof, bad of me. That's why I'm smiling and laughing. I would like to highlight what unit we're about to begin. How does everyone feel about the due date of project 2? I should just see how many of you have turned it in. It was due the 20th. That was a weird Thursday. Would it make you all feel better if I just click this and change it to the 30th? Or would that make everyone angry? Might make everyone angry. Looks like 7 people have turned it in. I'm just gonna do it anyways, and y'all just gonna have to be angry at me. Oh, I need to do this anyways, just in case you upload something you didn't like. And we're gonna change this to the 30th. I really feel like I should be begging your apologies that I'm so bad with due dates in here. Especially to those students that are like on top of it and you follow the due dates and get stressed when you're not meeting them. And then I'm just this flippant, I'm going to call myself bad names, person that's just like, just make sure you turn it in, make sure you get it done, make sure you do it well and turn it in when you're happy. And then I don't bother to fix any of the due dates. They're just there to keep you moving, like I say, and they're soft deadlines except for this midterm. So I'm hopeful that I'm not stressing people out too much, because that's the one thing. I don't want to stress people out, but also I don't want people to fail. And there's a happy median between there, and I have definitely not found it this semester. Okay. Enough of that. Even if you miss the 10:30 deadline, keep working, turn it in. So let's talk about the Unit 3 project. And this will give you a nice highlight of what you're about to learn in Unit 3. Now, those of you who have lived life a little bit, and what I'm saying, what I'm trying to be careful about what I'm saying is, those of you that own your own home, own your own car, you filled out your FAFSA or whatever, you're paying the loans on your student, whatever, you will hopefully find this project, this unit, pretty simple, because we're going to look at financial mathematics. So if you look at the first task, I'm forcing you to go buy a car. You don't have to use an online shopping service like cars.com or whatever. You can go to an actual lot if you want to. My experience is, if you pretend like you're wanting to buy a car, you're going to be talked to by someone. And if they can get you into the loan office, you might leave with a car, depending on how good the salesperson is. So maybe don't do that if you're worried about pressure buying of things, which is a problem for me. But you're just going to find a car, a real car at a real place. You're going to pick an APR off of this table. You're going to calculate the cost of your car, like your monthly payments for the car, based on 3 different term lengths. You're going to calculate how much did it cost you to buy that car based on the fact you borrowed money. You're then going to check out a early payoff. You're going to compare this stuff, and you're going to write a nice little paragraph explaining your choice of what's the best. Right? So car shopping, hooray. You can be realistic about the kind of car you're going to purchase, or you can go crazy and go buy a Bugatti for $350,000 or whatever it is. Do whatever you want. I'm looking to see that you understand the connection between APR and the monthly payments and how to calculate your total cost and all that mess. All right, that's the first task. Second task, it says 2A. It should just say task 2. We used to have 2 options here. You're going to buy a house. So first you bought a car, now you're buying a house. I want it to be a real house that exists out there. So go to Zillow or wherever, find a real house. If you want it to be realistic to your life, find one that you might be able to afford. If you want to dream big, go find a mansion, whatever, doesn't matter. And you're going to do all the calculations in terms of monthly payments and the rest. Third task, you're going to pick a job. You're going to calculate your taxes based on the median entry-level income of that job. And you're going to calculate your taxes. You're going to calculate your take home, what your paycheck will be, and then you're going to react to your stuff, to your paycheck. Now, the assumption here in my mind is that you all are taking this class for a particular reason, meaning you're headed towards some sort of career that your studies at Jackson College will get you to. So I would encourage you to pick the field that you think you're going to end up in when you graduate from Jackson College, when you get that certificate. Because the question I'm really asking down here is it worth your time to take my class and all the other classes that you have to take at Jackson College to get the certificate or the degree or whatever you're pursuing? Is it worth your time financially or otherwise? I mean, not all choices in life are about money, but that's the thing. You're going to look at, is it going to pay off? And then finally, you're going to buy some stock. I'm going to give you $1 million, pretend money. I don't have $1 million to give everyone. You're going to invest it in some stock. I've suggested you purchase the stock you chose for project 2. And then you're going to calculate your profit. All right. I love this unit. This unit is awesome because this you all experience every day. But it can also be super challenging, especially for students who have never had to do these things, because there are 100,000 formulas you have to keep track of. Not that many, but there are quite a few formulas and lots of vocabulary. But my hope is that once we've gotten through this, you will be a more savvy shopper when it comes to buying cars, buying homes, student loans, all the money things. Okay, so we're going to start with section 3.1. We don't get to that exciting stuff right away. We're going to start with savings accounts. Where are you, friend? PowerPoints. Hooray, unit 3. Can you believe we're halfway through this semester? I should ask how many of you are starting your second 7 weeks classes and hope that they are not highly time consuming. Because if you spent your first 7 weeks focused on those classes and not this one, you know, rightly so, because those are more pressing deadlines. I don't want you to get in trouble now focus on any second 7 weeks and the mountain of work in this class overwhelm you. There are students who have yet to turn in an assignment, which I feel really bad about. Sometimes I feel like that's my fault. Okay, well, I just saved this as a PDF and it's missing. Here we go. So we're going to start with interest. And you kind of already know this, but we're going to give you a new formula that's related to this y equals mx plus b thing that we learned back in unit 2 that you'll be performing on the exam. And so we're going to talk real specific about simple interest and then where they show up. Spoiler alert, simple interest does not show up that much in real life. Okay. Let's start here with the definition of interest. It's a fee paid for the use of money. You may listen to the news, and the Federal Reserve is the entity in America that determines interest rates on things. So they have monetary policy, and they try to use it to manipulate the economy to either keep inflation in check or keep growth in check or whatever, right? So stuff that I don't fully understand, but that's one place where the interest is set. And it was not too long ago very, very low, like 0% interest for your banks. And that meant great things for borrowing money and meant terrible things for saving money. And now the Federal Reserve is raising interest rates. They've done it a couple times. And so it gets a little better in terms of savings, but it also means really bad for people trying to buy money. So for us little people that need money to buy a house, it's more costly to buy a house. For big business folks, it's more costly to borrow money to invest in the company, that kind of thing. This entity, there's the World Bank, that's like Europe and other places that runs it. Many countries have their own little thing going on, and then Russia has its own little thing because they're like totally isolated from the world in many ways. So this interest thing it's a very interesting financial thing. I think it would be fun to study, but I don't know a whole lot. I like to call this the cost of money because I'm the type that buys money more often than sells money. You can think of selling money by either purchasing stock, that's kind of like selling money, or giving it to the bank who turns around and gives it to someone else. We already know this, by the way. There's two types of ways interest is paid. There's simple interest, and that's just a fixed amount that doesn't change over time. The amount of money that's loaned, you get a percentage of that paid to you. And then there's compound interest, and that is a percentage of the original amount plus a percentage of the new amount done over time. This is the far more common one. We're going to learn about that in section 3.2. Okay, so here goes. Tax season is coming. You get a $600 tax refund, and you're going to invest it in an investment vehicle, whatever this is, that pays 5% interest, 5% simple interest, key word. So we're asked to calculate how much would we add to the account each year. Well, remember, it's a fixed amount. So this takes us all the way back to unit 1.1, and that is, how do we calculate a percent of? Well, we multiply it by the decimal version of that percent. I am pretty certain this is $50, but you know, I'm on camera. There's all these people watching. The pressure is just too much. Yeah, I'm wrong. It's $30. Ouch. Did you catch that? We took the amount of money that was invested, we multiplied it by the decimal version of the percent, and we get the amount of interest. This is $30 per year. And this doesn't change. For the lifetime of the investment, we're always going to get $30. It's a really bad deal. You don't want to do simple interest investments. So then we're like, hey, let's redo this, and let's put some labels on this. Let's call this thing P. Let's call this thing R. So if we want to calculate interest for 1 year, we just do principal times rate. Right, that's it. That's a general formula. So now we could say, well, how much would you get if you invested 1,000 at 20% simple interest? Well, it's 1,000 times 0.2. How are we doing, y'all? I'm going to keep going. I'm going to assume you're good. So we did this table already. You did it way back in, oh, awesome, y'all. Yeah. Way back in 2.1, when we first encountered the difference between linear and exponential things. We know we're going to get $30 here. This is going to be $630. We're going to add another $30 here. So after 2 years, the total interest would be just $60. So $660. Add another $30 here, we're going to be at $90, $690. Add another $30, we'd be at $120, so $720. Right, so I'm adding this total to the original amount. Here we go, $150. So this is $750, and then, oh, I almost said $780. And then we're going to skip 10 years. Whoa. All right. If in 5 years we earned 150, the next 5 years will earn us the exact same amount. So we'll have a total of $300 interest earned. We'd end up with $900. Right? Fixed interest. That's linear, fixed. Now, if you notice what's happening here, the value of the account is equal to the total interest earned plus the initial amount. So that we just said it. What is the relationship between the number of years that have passed and the total interest earned? Oh, wait a minute. We're doing 30 years and we're like, or $30 after 1 year, 30, after 2 years, 60, after 3 years, 90. What's the connection between this 30 and these numbers? What's happening? I'll let you all say it. Every year add 30. Nice. There's another connection. How does this, what does this number do to this number to get this number? Yeah. In other words, we take the total interest, which we wrote before, which is P times R, and we multiply it by the amount of time. There's our first formula. Interest equals the principal times the rate times the time. Okay. So interest is the principal. I don't know why I'm writing that. We have it right here. I equals PRT. So these words you should get comfortable with. What do we mean by interest? This is a dollar amount. What do we mean by principal? It's the amount borrowed or invested. What do we mean by rate? It's a percent, and this often says interest rate. It's the two words together. It's a percent that needs to be converted to a decimal for our calculations. What do we mean by time? That's typically years. And then the thing we haven't talked about is the future value. We call that A. This is a dollar amount. This unit here is years. A is the value in the account after T years. So it's what is it in the future? You need these things because these words, these concepts, these I's, P's, R's, T's, and A's, and the words associated with them are used in 3.2 and 3.3 and 3.4. Well, and that's it. Those 4 sections. Okay, so I think we already did this. We're just supposed to write that interest is the principal times the rate times the time. And then if you think about the future value, if we go back to our table, here, this thing was P times R times T. And then to get this one, we just added to it this amount, P. In other words, there's 2 ways we can write this formula. The future value is the interest we earned, meaning this value, plus the principal amount, meaning the initial investment in the account. Well, if we put the 2 together, we can just say, well, this is the same thing as saying the future value of the account is the principal plus the principal times the rate times the time. Let me blow your minds. Do you remember this thing? Y equals mx plus b. Do you remember how b was the initial value? What? Do you remember how m was the rate of change? What? This thing is just y equals mx plus b. That's all it is. So if we want to use our formula we just wrote to calculate the future value of an account that has 600 invested with 5% interest over 30 years, that future value is equal to 600 plus 600 times 0.05, which we know is 30, times 30. Well, I know this is just 900. It becomes 600 plus 900, so $1,500. Not a great investment when you think about this 30-year thing. Okay. How about you all try number 2 for me? Let me give you 3 minutes to answer number 2. Set a timer for 3 minutes. The did you get it problem. Oh no, already? How'd you get it? I know, I'm pretty sure you're right. I don't actually know. Nice. Did you multiply by 3? Let me see. Let me see. I think you did. Nice. Okay, good, good. Crushed it. The initial amount, 3,600 plus 3,600 times 0.08 times 3, because it's over a 3-year period. Nailed it. 44.64. Excellent. Spot on. Okay. Author asked us to do something crazy here. He's like, hey, do you remember factoring in high school? Like, do you remember when there's something in common between two terms? And so you can divide it away. And what you divide away, you multiply, and P divided by P is 1. And PRT divided by P is just 1 times R times T. Oh, okay, good. I'm glad you remembered that, because here's another version of the formula. And for me, I'm like, I don't know. There's a reason we give you this version. Because it looks very similar to the exponential version, which in some ways is not helpful, because then you might confuse the two. So really, you decide which of these 3 versions is most helpful for you when working. Oh my goodness, that's scary. That's scary. I got to clean up a mess over here. You can use any one of these 3 versions to work with future value of a simple interest problem. I would say, in my opinion, maybe I should say, in my travels of this class, this one is the one students tend to use the most. This one's the same thing. And then this is a very good conceptual one. So, I think it's nice to know the 3 of them, to know the connection between the 3. Really, between these 2, you just kind of pick the one you want to work with and run wild. This is a very useful formula if we want to straight calculate interest. If we're not interested in the amount in the account, but instead are the amount we earn over the lifetime of the investment, we're going to use this one. The key word you're looking for, though, is simple. If it doesn't say simple, then it's something else, and these formulas don't apply. So here we go. To meet payroll during a down period, United Ceramics needed to borrow $2,000 at 4%. There it is, simple interest. Ooh, wait a minute, 3 months? Remember, these T's are always in terms of years, because the interest is always assumed to be an APR, an annual percentage rate. So even though it says 4% interest for a length of 3 months, this 4% is the yearly interest rate. It is rare for interest rates to be reported, I think by law, actually, interest rates have to be reported as an annual interest rate. They can't report something else, because it's misleading. Like, if you wanted to know the monthly interest rate, divide this thing by 12. So 4 divided by 12 is 0.33. Right? So if you saw that you were only being charged 0.33% interest, you're like, oh, that's like 0% interest. Awesome. Let me borrow $2,000 from you, please. That could be very misleading. It could trick people into thinking the interest rate is lower than it actually is. And mostly because we've trained everyone to think in terms of yearly interest rates. Okay, so that means when we work our formula, let's see. Oh, wait, we're supposed to guess. How much interest will you think? Anyone have a good guess? Ooh, Maya, love it. Except when we say how much interest, we should say dollar amount, which might have been what you meant, $25. And not the 25%. So just be careful with the percentage versus the dollar. Like when should we think about what? All right, let's run the formula. Now notice it says how much interest. So we don't need the future value formula. We don't care how much is going to be in the account. Really, this is how much is owed. Instead, we're just going to do this I equals PRT. And we know the P, the R, and the T, right? The P is the initial amount we borrowed, 2,000. The R is the 4% that we're going to put as 0.04. Please pay very close attention to writing out the percentage as a decimal. You'll get crazy numbers. You might forget it once or twice. Don't worry if you forget it, just fix it. And then T, I'm going to convert this 3 months into years using a conversion factor. And that is that 1 year is the same as 12 months. And so this is 0.25 years that we're going to plug in. Maybe that's where your 25 came from. Which is good thinking if that is where it came from. Nice, that's good thinking. We're going to use that because now we're just going to plug this stuff right into our formula. So the interest rate equals 2,000, or sorry, not interest rate, the amount of interest times the 4% times the quarter of that will be charged in those 3 months. 2,000 times 0.04 times 0.25 equals, we are going to pay $20. And look at that, you weren't too far off. Lucky guess. It won't always happen that way, that the amount of time is similar to the amount of interest. Did you notice, by the way, that 2,000 times 0.04 was 80? So each year, you're going to owe $80 in simple interest on this loan. And because we're paying it in 3 months, we will just need to pay $20 because that's a fourth of that 80. Okay, nice. That's I equals PRT. Turns out we can use this formula to find any of the other items. So maybe I give you the amount of interest we charge you and we solve for the principal, or we solve for the rate, or we solve for the time. That's, oh, this one's about a monthly payment. This is a good one to look at if it's simple interest, which is what any of your installment loans are, more or less. They calculate the total fees off of a flat rate, and then you pay a specific amount. You just divide by the length of the loan, and then you get your equal monthly payments. So this one, we can do that here. We're going to owe $2,020 after the end of the 3 months. So if we divide this by 3, this is how much we'd have to pay per month to pay this thing off, which is $673.33. And then the last month we'd have to pay $3.04 to account for that 1 penny. This only works for simple interest because the amount you're charged never changes. With compound interest, it's a little different, and we'll talk about that on Wednesday. Okay, now let's look at a couple other little examples here. So what we're going to work with, what we're going to practice here is understanding which formula should you use, and then what are we trying to find. So here's our scenario. We got this married couple that received an inheritance, and they invest $15,000 for 10 years, and they get $9,150 in simple interest. And our job is to figure out what is the rate that the investment paid. So if I were to list out what we've been given, I know what this capital I is. It's $15,250. I know what the time is. It's 10 years. And I know, oh, I am so wrong. Did that bother anyone? It said we received $9,150. That's the amount of interest we earned. I know the principal, the amount we invested, is $15,250. What I don't know is the interest rate, question mark, right? This is a percentage or a decimal. So we have 4 formulas we could work with. We could use the A equals PRT, but we don't actually know the A, although we could calculate the A pretty easily if we wanted to. That's the sum of these two. But we don't need it, so let's not even bother with that because that might actually be misleading. We could just write this out, 9,150. Let me make this clear. I equals the principal times the rate times the time. That's the formula I'm going to use. So I'm going to take the 9,150 and say that's equal to the 15,250 times the thing we don't know times 10. Solve that for R. This is where we could do the graphical method, but I think that in this case, it might be more of a pain. I'll go ahead and multiply these two numbers together. And then I'm going to divide both sides by that result. I don't know where my drawing pen is. That's why this looks so bad. I'm having to use my mouse. So I'll divide both sides by this, and we have the answer. Look at that, exactly 0.06. Now, we most often talk about the rate as a percentage. So this is 6%. How do y'all feel about that? Actually, don't tell me. See if you can't answer number 2. Be careful, it's a little different. And note, I'll just tell you this because it's the one thing that can be confusing. He's saying, assume they invest the same amount, even though it's not explicitly stated. Right? Assume that that principal is 15,000. Okay, you do that while I give you 5 minutes to try it. Set a timer for 5 minutes. was ready that time. How did we do? Did y'all find this? So I wrote the stuff. Now we just got to put it in if you weren't able to do this. And remember, the order you multiply things doesn't actually matter. I mean, I'll leave them the order they're written in our formula just to help everyone know what went where. But here's this. This is some sort of number. Oh, let's just multiply it out. That's 1372.5. So if you think about what that means, we just took the investment amount, 15,000, multiplied it by 9%. This is how much money we're going to get each year, $1,372.50 each year. So when we divide both sides by this amount of money earned per year, I don't know why I'm putting the dollar signs in there. We're going to get the number of years it's going to take us to get to the 9,150. Presumably it's going to be less because the interest rate is 3% higher, right? So that's a great way to keep track of whether or not our answer makes sense. And it does. This number is smaller than the than the 10 years from before. We could talk about, hey, it's going to be 7 years, right? Yeah, because the way simple interest works, you get it at the end of the year. So we'd have to hit 7 years. So it's between 6 and 7 years. It's not a whole number of years that hits this. So we're actually going to make a little bit more than 9,150, unless we can convince this investment person to also pay us a monthly amount. We could divide this 1372.5 by 12, and then that would give us the amount they would give us each month. Okay. This kind of interest, I think most people are the least familiar with, because it's not the one you encounter most often out there when you go shopping. The closest one is if you use like Rent-A-Center kind of thing. They kind of calculate all the fees up front that you're going to pay for the full year. And then from that, they calculate a monthly payment that's a fixed amount. So all of those installment loan type things work this way. Another similar one is when you get like one of those credit cards like I did for Best Buy, where you charge the item and they charge you a fixed amount of interest each time. And then if you pay it off, you don't have to pay the interest if you pay it off at the end of the length of the loan. Otherwise, you get all this interest tacked on, and then you get interest charged the same way. Yeah, that's a great question, Maya. A CD, boy, this would be similar, except that I believe CDs are still exponential, because they tell you the interest rate, and then you're earning interest on interest throughout the life of that loan, or throughout the life of that investment. Usually you can't take the money out. So I think those are exponential. The ones that are simple interest are bonds. Like if you buy a government bond, those are definitely simple interest. I'd have to look at that. I don't really know, to be honest with you, but yeah. The one thing I do know about CDs is that they're like, you're not allowed to touch the money, or there's a penalty if you take it out early, which is kind of the same thing with bonds, but kind of not really. Cool. Okay, so we're going to look at why simple interest in terms of a savings account is not fair. Our author, I like what he says here. When you put money into a bank account, so a savings or checking account, either way, the bank is essentially paying you to borrow your money, because then they take your money and they give it to someone else. So like if we could look at it real quick. Bank savings rates today, just real quick. So we kind of want average. All right, here's, oh, hey, they have gone up. Wow. Right, so this is what it used to be, 0.61%. Now it's at 3.11%. Oh yeah, okay. So let's just take this rate as of October 10th. The traditional savings account was 3.1% interest. So you give your bank your paycheck each month. That's what I do. It's auto deposited. And let's say I left it in a savings account that earns this amount of interest. Now I'm going to go to the project. I gave them my check and they're like, we'll give you 3% interest. This is APR, by the way. By the end of the year, they'll give me 3% of the amount. And then one of you all was like, I need a car to get to work. So you go to this same bank and you're like, I need to buy a car. I'm going to buy a new car. Oh, look at this. And here's the average new car APR. And let's say you have a low credit score. Let's say you're at the 601 to 660. They're going to give you my paycheck and they're going to charge you 6.7% interest from my paycheck for you to borrow that money. So they are making 3.69% interest off of my money. And you see why I chose the higher one, right? Because that interest rate is up. Some of these interest rates, whoops, in the project were lower. Now, if let me search for this now, because I did this way back in, I did this summer, like in July is when I put together this project, and interest rates have changed a lot since then. So let's do average car loan rate by credit score. I'm going to guess that these have gone up. This is not the place I'm going to look at. Is this the one? Yeah, I think this is like the same place. No, it's not. Okay, maybe I just need to move on. I want one of those little tables. Here we go. Wow, this one hasn't changed. Is this an old one? Updated 5 hours ago. For new and used cars, that compared to the one I just looked at, it's exactly the same. Hey, car rates haven't changed. Great. Okay. I took all that time just to, to help illustrate how the bank makes money. And if you notice, they make more money off of people with lower credit scores, and it tends to be people with lower credit scores typically have lower incomes. Not really, right? Because it's more about how you manage your income in terms of your credit score, but you can still look at those numbers. Okay, so what you should do, right, is take your paycheck and go find the person that wants to buy a car and say, hey, I'll loan you my money for 6.7% interest, and then you'll make all of the interest yourself. But then what happens if they don't pay you back? And how do you track all the money that they owe you, right? So that's why you don't do that, because that's a lot of work and you need legal and whatever. Okay, so instead you're going to invest your 1,000 in a simple interest card at 3% interest per year, right? So we do 1,000 times 0.03 times 1, which equals $30. Yay! But then you have this 10,030 in your account, not this amount, but it's simple interest, right? So in the next year, you're going to only get $30 again, even though your account balance is now higher. So what you could do to trick this is you could say, all right, let me take that 1030 out. I'll pull it out and I'll open a new account and deposit 1030. How much would I get in the account after that? So if our new balance was 1030 and we still get 3% interest, here's how much money we'd earn. We should have $30.90 interest. What percent is that? Although this is not the question he asked. I'm sorry, this is the answer down here. I should have read this a little more closely. If we had gotten a full 3% interest, we would have gotten $30.90 in our new account. What the author says is, hey, what percent is the $30 of the 1030? So we take this $30 and we divide it by 1030 and we get the percent $30 is of 1030. So 30 divided by 1030. Oops, that's 0.29126. Or approximately 2.92% interest. We're earning less than 3% interest in the second year if we don't pull the money out and then redeposit it. That's why it's not fair, right? Because we didn't do anything with this $30. We let the bank keep it. Which is why there's the compound interest thing, right? Because the compound interest says, oh, here's the amount in your balance. So we'll give you 3% on the new total balance. So you're earning interest on the money the bank gave you. Remember, they earned interest on the money you gave them, and they're giving the difference between the two. They keep and they give you a little piece of it. Okay, how do y'all feel about this? Let's do the 3-1 lesson check. Multiple attempts, no. Looks like I haven't fixed all these for unlimited attempts. So in case you have gone ahead and done this multiple times and had it wrong, I'm fixing that for you. Yeah, let's talk through number 3 one more time before I do this. So number 3 says, first let me actually read what it says, because I just brushed over it super fast. Number 3 says, forget about the original amount and just think of the 1030 in your account at the end of year 1 as a new investment. If you get $30 in interest over the next year, what percentage did you actually get? So remember, percent equals the part divided by the whole. So in this case, what he set up, the whole is the amount in the account, the 1030 at the end of year 1. The part that we're being paid is the $30 that gets deposited at the end of year 2. So we're wanting to say $30 is what percent of $1,030. So when we run these numbers, we get this 0.02962, blah, 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 blah. So while we're told that we're getting 3% simple interest, I mean, we are, what happens is as the interest gets deposited into the account and we don't earn money off of that interest, because this is simple interest, the percent profit is another way to think of this, or the percent interest we're getting is going to decrease over time. So if we kept our money in here for 100 years, we're essentially earning 0%. When you think of the current account balance relative to the amount of interest handed to you at the end of that year. Whereas when we work through the compound interest thing, if you leave your money in there for 100 years, in that 100th year, the amount of money deposited into your account, this amount, is going to be relative to the previous year's account balance. So if you have $1 million in there, you're going to get 3% of that $1 million added in, as opposed to just $30, which is what question 3 is getting at. So anytime you're investing, you want compound interest as your investment, so that when things grow, the amount of money you get also grows. Cool, great question. I did a bad job explaining that for sure. Good. Okay, let's see. This is the 3-1 check. I just changed it, I believe, to infinite attempts. If you have attempted it already, you might need to hit refresh. If you got it wrong and are trying to attempt it again. Find the future value at the end of 3 months. That was this one. Is this the question we're doing? I think this is the one. Question 6. Yep. Find the future value. The answer is 2020. So 3.1 lesson check 2020. Let me just make sure everything's functioning the way it should. 2020. Submit quiz. Did I get it right? Fingers crossed. Got it. Nailed it. Money. Okay. I want you to try the 3.1 worksheet. Oh, I had it open already, of course. So let's do this. I will give you 5 minutes and you see how far you can get. Not this one. This one. Yeah. So let's take 5 minutes and you put together A and B. 5 minutes for A and B. Set a timer for 5 minutes. You can't hear a word I'm saying. Okay. I said that was 5 minutes. Anyone got the answer to number 1? And by one, I mean A. I don't know if anyone watches Judge Judy. She's a tough judge. Love it. 1,120. 2,000. That's the principal. By the way, it says calculate the interest. So all we're doing is I equals PRT. That's it, right? So 2,000 times 0.056 times 10, which is 1120. Turns out, so that's interest earned. That's not the amount of money that would have been paid to you, right? Or total. If we add this to the original 2,000 we loaned them, they, by the end of 10 years, they would have paid us $3,120. So then here, did anyone fill out the table? Here's how I might have done it. A equals 2,000 plus 2,000 times 0.056 times T. And then I would have ran myself to Desmos and typed that in. Although I think I would have done f of x equals 2,000 plus 2,000 times 0.056 times x. And then I would have turned that, then I would have put a table in. Table, hello friend. And I would have typed f of x1. And then I would have done 0, 5, 10, 15, 20. And there is my table, just carefully smashed together. Okay, so I will just leave that. I'm not even going to copy it over. I'll just leave that there. 2,000, 2560. I guess I need a 25 as well. And I might even, just for fun, like click this so we can see, oh, look at that. It's a beautiful linear equation, just like we did back in chapter 2. Anyone got the answer to C? Use Desmos to find a linear regression model for your table? Sure you do. This is what you're doing in your project. This is what you're doing on the midterm. You better know how to do this for the midterm, right? You're going to have to do it. Y1 tilde x1 plus b. Oops, it's going to fail because I've used f of x1 up here. So I have to do f of x1 in order for this to work. Oh, it doesn't like it. It's not going to do it. Okay, so I got to change this. Oh boy. Oh boy. Okay, so we can't do it that way. We have to have the actual table typed in here for it to work. So 0, 5, 10, 15, 20, 25. You get out of here. Let's see, 2,000, 25, 60, 31, 20, 36, 80, 42, 40, 4,800, and then y2 tilde m x2 plus b. Oh, look at that. There's our equation. This is a perfect linear model. Y equals 112x plus 2,000. I'm going to make you all do the parameters. I'm not going to tell you that answer. And I'm going to let you try to figure this one out because I already kind of told it to you. And then I'm going to give you 5 minutes on this one. All right. So take 5 minutes and see if you can't answer number 2. And we'll talk about it. Set a timer, 5 minutes now, please. Thank you. Yo, got this one? I'm going to just write some stuff out while I wait for your responses. Oh, we got it. We got it. We got it. 3% per year. Let's see. I don't know the answer. Maybe I should have known the answer before I asked. So I know I need interest equals P times R times T, not future value, because we're just asked to calculate the interest rate. This is the simplest formula. The simpler the formula, the better, right? You want to use the simplest formula you can. I'm going to note that after receiving the 2,000 back, you divide and invest all 2,000 for 10 years. Okay, so we are taking this $2,000 that our family gave us, and we're going to invest it in simple interest, right? So it's the principal is the 2,000. The time is the 10 years. And we're told that we're receiving $600 spread out over those 10 years. So this is the amount of interest we're earning. And our job is to figure out the rate, the interest rate, which I believe we already know, 3%. I think you're right. So we're going to do 600 equals 2,000. Now this time I'm going to switch the R and the T. I don't know if that's helpful to anyone. And that's the 10 times the, oops, let's not put an R, times the, or T, let's put the R times the R. We're going to divide both sides by that 2,000 times 10, which just means pop a zero at the end. So by 20,000. And is it going to equal our interest rate? Let's see, those go away, those will go away. We just have to take 6 and divide by 200. Yeah, nailed it. Good job. 0.03. Sorry, maybe that was an overreaction. I'm always excited when you all get things right. 3%. 3% per year in simple interest. Love it. Love it. How's Alex going, everyone? You enjoying it? Loving it? Alex is going to maybe frustrate you a bit on this. I don't want to waste anyone's time. We've done it all of 3-1. So I'm, like I said, I'm going to leave these 2 questions because these are essentially unit 2 questions for you all to figure out. What's the connection between this and this? This question here, the slope and y-intercept, this is exactly what you're doing on project 2 and the midterm, where you're going to tell me the parameters, you know, the slope and the y-intercept. And then here this one is newer. I already told you this answer, but I want to let you all try it. So I would love to answer any questions anyone has about anything. If there are no questions, I would love for you to take off and have a great day. So ask away, y'all. Laquita, do you have a question for me? Okay, do you want me to turn off the recording?